Hey everyone, in this video I'll demonstrate evaluating derivatives using the quotient rule. Now in this scenario we'll want to have a function of x that divides two other functions of x, say g of x and h of x. Now here what I've done is I've labeled the top function high and the bottom function low so that we can use this mnemonic I've created that rhymes. And it reads low d high minus high d low square of what's below. So you'll do low times the derivative of the high term minus high times the derivative of the low term all over the square of what's below. Okay, let's have a look at an example. I'll go ahead and rewrite that for you so we can have it later on. And the example reads f of x is equal to x cubed over e to the x. Okay, so I'll go ahead and label the first term, or the term on the top, high, and the term on the bottom, low. So using the quotient rule formula, we'll find that f prime of x is equal to low, so e to the x, d high, so the derivative of x cubed, which using the power rule is 3x squared, okay, minus high, or x cubed, d low. Now if you recall, the derivative of e to the x is simply e to the x. And all of this is going to be divided by the square of what's below. So e to the x squared. And I'll go ahead and simplify here. 3x squared times e to the x is exactly as it reads, 3x squared e to the x. And x cubed e to the x, well, that's also as it reads, x cubed e to the x. And now e to the x squared, when you raise an exponent to an exponent, is the same thing as multiplying. So that'll turn out to be e to the 2x. And that is the answer. Notice that we started, and really the key to these problems is recognizing that we have a function of x divided by a function of x, because really we would like to avoid this type of problem if at all possible, due to the fact that it's a lengthy equation and it's really more difficult to memorize than d12 plus d21 or something like the product rule or the power rule. So if this was possible to flip it up to the numerator or do something like that, we'll go ahead and do that. But in this case, it's easiest just to go ahead and run through the product rule, or the quotient rule, should I say. So let's have a look at one more example. Let's say that f of x is equal to 2x to the negative 2 plus 1 all over x to the negative 5th plus 3. Okay, so if you recall, the rule or the formula that we're going to follow for this type of problem is low d high minus high d low all over square of what's below. Okay, so low becomes x to the negative 5 plus 3, rewriting, d high, so the derivative of 2x to the negative 2 will become negative 4x to the negative 3 using the rules from the power rule. And given that the derivative of 1 is just 0, the derivative of any constant is 0, okay, minus high, rewriting the top term, 2x to the negative 2 plus 1, d low. So derivative of x to the negative 5 is negative 5 x to the negative 6, and the derivative of 3 becomes 0. Okay, and we're going to divide that by the square of what's below. So I'll keep that as x to the negative 5th plus 3 squared. And that is f prime of x. Okay, now we could do some simplification here, and I'll go ahead and run through that for you. X to the negative 5 plus 3 times negative 4x to the negative 3. Okay, we'll go ahead and distribute each term into this term. So x to the negative 5th times negative 4x to the negative 3. Well, that's negative 4x to the negative 8th. Okay, and then we have plus 3 times negative 4x to negative 3, so that becomes negative or minus 12x to the negative 3. Okay, and then we'll have a big minus sign here. We'll do and do 2x to the negative 2 times negative 5x to the negative 6. That becomes negative 10x to the negative 8. And then we have a 1 times negative 5x to the negative 6. So that becomes negative 5x to the negative 6th. Okay, and so I'll go ahead and put all of these in parentheses just to make sure that we distribute properly. All of that, of course, will be divided by x to the negative 5th plus 3 squared. Okay, so we could simplify this out. We'll have negative 4x to the negative 8th minus 12x to the negative 3. Okay, we have minus a negative, which turns into a plus 10x to the negative 8th. Minus minus becomes plus 5x to the negative 6th. And all of that is going to be, again, divided by x to the negative 5th plus 3 squared. So, continuing on with this problem, we'll go ahead and combine like terms. We have negative 4x to the negative 8, and we have a plus 10x to the negative 8th. So 10 minus 4 becomes 6x to the negative 8th. Then we'll have plus 5x to the negative 6th, and then minus 12x to the negative 3. All over. Now we have a term here of x plus 3, x to the negative 5th plus 3, and we'll square it. So what we'll go ahead and do is use the FOIL technique. And so that will give us x to the negative 5th times x to the negative 5th, which is x to the negative 10, plus the outside, so x to the negative 5th times 3, so 3x to the negative 5th, and then again plus 3x to the negative 5th, and then 3 times 3, or 9. And so we could continue to simplify here, and we could combine these two terms, but basically this is the formula you'll want to follow for any type of problem that involves a function of x divided by a function of x. Okay, hope that helped. Thanks for watching. Be sure to subscribe below for more videos and help with math and calculus.